Actually, just a quick question, just for my own, to gauge the audience. How many people have used MongoDB or currently use MongoDB? OK, great. So this won't be all new for folks. So as Bruno spoke about in the beginning, I think everyone would agree that the main driving force behind NoSQL and the reason a lot of these new database technologies came about was to solve the big data problem, the horizontal scalability problem that relational databases ran into at scale. But what I wanted to talk about today, even though Mongo is like all those other NoSQL solutions in that it does have a big data story. That's what the Mongo and MongoDB is for. But I wanted to convince you all today that MongoDB is a great database even if you don't have big data, if you don't have a big data problem. So what is MongoDB? MongoDB is a scalable, open source, high performance, document-oriented database. And that's a mouthful, but hopefully by the time I'm done with this talk, all of those will make sense. But first, before I talk about why MongoDB is good for just any size of data, I just want to give a little background on what MongoDB is so you can have a mental model of what we're talking about. So first thing is the storage model. MongoDB is really not all that different at a high level from a traditional relational database in the sense that you've got these things called databases. Inside databases, there are collections, and that's the term that represents what in a SQL world you'd think of as a table. And then whereas in the SQL world you have rows, in MongoDB you have what are called documents or objects. And really, documents, objects are, I have an example here that I like to go through. It's a big block of JSON. And so JSON is the JavaScript object notation. It's become really popular. First it was part of the JavaScript language. It became very popular as an API data exchange format. Fast forward a little bit, the document-oriented databases like MongoDB, CouchDB, they use JSON also as a storage format. And so this example here is a little example of a blog post. And what you can see is an ID, and everything in MongoDB has an ID or an underscore ID. That's one of the main tenets of how documents are stored. And then here we've represented an author as a nested object. So it's got a name and an email. You got the body of the blog post, a date, a location. So the reason I included this in there is one of the cool things about MongoDB is it understands latitude and longitude natively. And so I'll explain a little bit later. You can do all sorts of cool geographic searches with Mongo. You don't have to sidecar on another technology into your database to do geo-search. This here we show, whoops, sorry about that. Show how, if you have a blog post, you might want to store comments to the blog post. Here we show an array of nested objects. Each one has user upvotes, downvotes. And one of the cool things about MongoDB is, let's say you implemented your blog system and this is what your data model looked like when you launched, and then product manager comes rolling in and says, hey, I need to have tagging. We need to be able to tag these blog posts. It's a new feature. Well, Mongo doesn't enforce schema. Your data has schema, but Mongo doesn't enforce it. So if you need to go and add the tags field, which is an array of, in this case, an array of strings representing topics that the blog post is about, you can go add that. You don't have to do an update schema, which, for those of you who've updated big schemas in SQL, can take forever. So this is basically the storage model of MongoDB. And it's very different than a lot of the other NoSQL solutions. It's really, the term object database is not what we like to use, but it really is a database that stores very rich objects. It's not just key value pairs where the values are numbers or strings. The values themselves can be other objects, arrays of objects, and it's infinitely recursive. As deep as you want to go, you can represent data in a very rich way in MongoDB. So I talked about the storage model. How do you access data in Mongo? So another thing Mongo, I think, borrowed correctly from the relational world is it has the idea of a query language. And a lot of the NoSQL solutions actually do not have a query language. You look up data by indexing it, and you look it up by ID, you structure in a certain way. MongoDB likes the idea of you can query your data however you want to. And some examples here. Actually, this is really cool. The query language is also, in JSON. So this is an example here in our blog post. You can see, there's an author field, and it's got a nested name. So you can say things like author.name is Mike. And the next one might find all blog posts with ratings greater than 2. Another cool thing is, if you notice, tags wasn't just a single value. Tags was an array. But if you want to find all blog posts where the tag software appears as one of the tags, you can do that. And it handles multi-indexing really well. And then things like sorting, pagination, or cursors that sliding windows through your data. Mongo does that really well. The query language, like I mentioned, really mathematically complete. It's got a whole list of predicate operators, like in, nor, not, and, or. It supports regular expressions in the query language. So if you want to search for strings with a regular expression matching search, you can do that. It also supports embedded JavaScript for where clauses that really don't fit with the query language. So if you want to write a little snippet of JavaScript that you use to troll over every document in a collection and return all those that match and reject all those that don't, because natively it's JSON, the JavaScript works really well there. It's got a group operator, which I won't go into the details, but allows you to do aggregations. One big thing about MongoDB, though, and I think this was mentioned with Bruno, no joins. So while you have a very expressive query language, one of the ways MongoDB solves the horizontal scalability problem is by not allowing joins. And we'll talk about why when I talk about the clustering and sharding. And then, also like the relational world, MongoDB says, OK, the query language is something we give you to very richly express how you want to find a subset of all your documents in the database. If those are slow, we have the concept of indexes, like in the relational world. So this is an example where if I know I'm looking up by the author's name all the time, I can specify an index on that field, and then the queries will go quickly. And so let me just quickly go back to this here. You can index on anything. So you can index not only on nested values, but you can index multi-values. You can index latitude and longitude. So like I mentioned before, geospatial is built in. So we had a loc field on that sample I gave you guys before. We can do things like look for all points within a rectangle. So bounding box type searches, searches with a bounding circle. So this one on the bottom is a point and a radius. So all things within 10 units of the point 40, 40. And it's actually cool. You don't need to just use it for geospatial indexing. I think there's one really pretty well-known MongoDB app, which is an infinite Scrabble board, or maybe not infinite, but incredibly large, and it uses the Mongo geospatial capabilities to represent that plane that all the tiles are on. So in addition to querying, it's got a really rich language for doing atomic updates to documents. So, is there a question? Yeah. Selects. So the concept of a select is really a SQL concept, but in essence, a select statement is a query, right? So these all here, all of these are examples of how you query in MongoDB. So instead of the language being kind of a syntax where it's select from where, this is saying find in the posts collection. So that db.posts, that's representing the actual table or collection you're searching in. So that's almost like the from. This is the where clause, and maybe this is what you're getting at, the projection part, which is where you strip out in SQL. You say, you know what, you might have this big object here, but I only want to see a subset. I only want to see ID and author. And actually the answer is yes, it does do that. I didn't show that in the example, but there is the idea of a field mask that you can use to
Sorry.
Yeah, you know, yeah, this is good.
Wildcards in your search there. What would the wildcard is just be percentage?
For the wildcard, you would not specify a constraint at all. So for example, if you want to say, well, the name could be anything,
No,
then you want.
the name starts with.
Yes, you'd use the regular expressions. So it's got the full regular expression capability built in. So I didn't use an example of regular expressions here, but instead of saying Mike in this example, I could put a regular expression like star Mike star or Mike star L or anything that the standard regular expression syntax supports, and you can do that. So getting to update operators. So obviously, you can create these documents in your programming language. You can insert them. You can save them. But you can also atomically modify them. So this is an example where, if you remember back here, we had a comments field that was a list of these objects that represented the comments. I could say to the system, I can make a new comment. This is an example. I'm using JavaScript, server-side JavaScript, but this could be any programming language. I make a new comment, and then I can tell MongoDB to push this comment onto the comments list, and it will do that atomically. It'll guarantee that that will either all happen or it won't happen, and if there are multiple threads trying to do the same thing, they will happen atomically, each one of them. And so there's a whole bunch of atomic operators, like, for example, increment's another good one. Let's say you're tracking votes. Actually, in this example we had one of the fields on a comment was a vote field. You could use the increment operator to atomically increment it by 1 versus dealing with a race condition that you might have if you were to pull the object out, look at it and say, oh, it's 4, I want to make it 5, and then save it back. So it's really useful. And then there's a whole set of them. So there's unset, increment, push, pull all. And so, the whole CRUD story here is really good with MongoDB. You've got a very rich query language. You've got indexes for making your queries fast. You've got insert and save operations. And then you've got atomic update operators, which allow you to atomically modify your objects. And I'm not going to go into too much detail with it here, but in addition to all the stuff I just talked about, there is an aggregation language. So I was showing you queries that are mostly about selecting a subset of your data. There's also all sorts of cool aggregations you can do. And the two ways you do aggregations in MongoDB are either A, with the aggregation framework. The aggregation framework in the 1x code line is somewhat limited in functionality. The 2.0 code line coming out really, really soon. One of the big features of it is a whole bunch more aggregation functionality, and it's actually really cool. And then there's MapReduce. So MongoDB does have a MapReduce engine where you can specify map functions and reduce functions, and then it runs over your data and computes the result and then saves that in another collection. Not sophisticated as Hadoop's MapReduce system. In fact, people have hooked up Hadoop to MongoDB. But for simple MapReduce style jobs, it's really convenient and works really well. The other thing I should say about Mongo that really is a subtle point but shouldn't be overlooked is that Tengen has gone through the trouble of actually creating a driver in every programming language for for MongoDB. So Java, JavaScript, Python, Ruby, whatever programming language you use, there is an officially supported driver from the makers of the database. And I can't tell you how convenient that is compared to a lot of other database technologies I've used, where there's either some protocol interface that you have to implement, or you really only have one programming language that you have to use to be able to interface with it. And so I'm sure most of you have played around with some of these drivers. And then the other thing about MongoDB, which, like all the NoSQL solutions, which I'll touch upon briefly, but it's not the main thrust of my talk, is that it was built with reliability and scalability from the ground up. Like all the NoSQL solutions, I think the horizontal scalability problem, like I mentioned before, is something that really drove this whole renaissance in database technologies that we're seeing now. So let me talk a little bit about the scaling and reliability and the clustering story with Mongo and how that all works. So when you talk about MongoDB clusters, there are two main concepts that MongoDB introduces. One is the idea of replication and replica sets. Replica sets are groups of MongoDB databases, and actually, if you can see right here, this is an example of a big sharded cluster, but I want to just focus on the gray box first. So if you have a deployment where you care about high availability, the story with Mongo is you create a cluster with replicas. Each replica has a copy of your data, and you can put a bullet in one of those set members, and all of your reads and writes will fail over to another member of the cluster. And there's an interesting voting algorithm that goes underneath the covers for the cluster to decide who should be promoted from a secondary to a primary. So for high availability, you use the replica set feature. The other reason you use the replica set feature is this is how MongoDB talks about read scaling. So if you have a scaling problem where it's about read throughput, what you do is you have your driver read evenly across all of the members of the replica set cluster. That spreads the read load across. It could be 2, 3, 5, 20 nodes. That's how you do read scalability. And then write scalability is handled with sharding in the auto sharding feature of MongoDB. So this is where you start to partition your data. And folks have been doing sharding in SQL for years, but mostly manually. The cool thing about Mongo sharding is that it automatically balances data across the shards. So each one of these vertical columns here on this diagram represents a shard. So you can imagine a scenario where you have a user collection that is just, for whatever reason, too big to handle the write load with one MongoDB node. What you do is you say, okay, I know some of you know what sharding is, but maybe some of you don't. You say that, let's say users A through C are on this shard, and then users C through F are on this shard. And you actually partition the data set into a bunch of different buckets. And then each bucket consists of a replica set, because you don't want any node in that bucket to be able to go dark, because you want to have high availability. So each shard consists of a little cluster of replicas, and then the entire cluster is a cluster of shards. And that's how MongoDB handles, the most badass of scaling situations. So, examples of folks who really scale big with MongoDB. Foursquare is a really famous example. They've got a cluster set up like this, where they handle an enormous amount of write throughput. So you can imagine having to handle every check-in for every mobile device running Foursquare on the planet. That's a lot of writes. And so they're an example where they use sharding, and there are others that you can look up online. MongoDB has a really good and public list of all of their deployments. Okay, but scaling aside, the main thing I want to talk to everyone about today is the fact that most people don't realize that while MongoDB really got popular because it has a great story around scaling data, it's really not just about big data. In fact, what I want to talk about is why it's really good for almost any size data set. And to do that, let me bring up an example of what we used to look at in the old world. So I'm going to continue with my blog post example. This is an example of how we might store that blog post that I was talking about in a relational world. And I've abbreviated a little bit for making the diagram simple, but as you can see, we've got our main table, which represents the blog post. The author, being another structured object, is normalized out into another table with, in this example, I just put a name and email in there. But then, you look at the comments, for example. And the comments, because it's a list of comments, this is a many-to-one relationship where you have the comment details, but then you have a pointer back up to the blog post. And then if you wanted to get all comments related to a blog post, you'd look up from that table with this ID, or if you wanted to get all the comments with the blog post, you'd do a join between those two tables. To get all the data back related to a blog post, or to get a set of blog posts back with all the data, you'd actually do a join with these 4 tables. And then when you're done with that join, you're not done with your work, because you're probably programming in a language like Java or Python or something that's object-oriented. And you probably are representing those comments and those tags in your code as an array or a list or some sort of data structure like that. And so after you do your big-ass join, you've then got to go through all of that data and now reshape it so that you have a parent blog post object, and that you take all those other pieces and shove them into the array values. This is what's called object relational mapping. I'm sure a lot of you have played with things like Hibernate, Active Record, and Ruby, things like that. And you know, for those of you who've done it, it sucks. I don't know how many of you guys know Ted Neward, but he's a famous author and programmer in the industry, and he had it right. It's the Vietnam of our industry. The amount of time, personally I can tell you, the amount of time in the late 90s and early part of the 2000s I personally spent as a programmer changing the shape of my data from the relational world to the object world, both for inserting the data, updating the data, expressing queries about the data. You know, either we've written object relational mappers or we've used object relational mappers, and if you use them, they're still not easy to use, especially if you want to get them to be performant. And then there's some things where you're like, you know what, screw it, I've just got to, you know, bypass the object relational mapper because it's not doing what I want to do. I mean, how many people have, you know, probably felt real guilty about doing it, but you know, put a comma-separated list of strings in a column in a DB and felt super guilty about it, right? But said like, okay, I'm not really going to search by this, so when I pull it out, I'll just do a string split on the comma, and I'll get into my object. And the reason you did that is because, frankly, relational model was not the right model for what you were trying to do. So you think about all that mess, and then you look at this, right? And you say, oh wow, this looks like the way I represent this stuff in my code. Like if you're a Python programmer or a JavaScript programmer, it looks exactly like this. If you're a Ruby programmer, it looks almost like this, where the colons are separated with that equal, greater than. If you're a PHP programmer, this is almost like what you'd use, except everything's arrays. And so it's arrays of arrays and nested arrays, which is still a very expressive data structure. This, in my opinion, is a more subtle reason as to why you should think about using MongoDB. Even if you do not have a big Mongo data problem, it's really great as a general purpose database. Actually, so some examples in my travels where I've seen it really good. So using it for accounts and user profiles, right? So you have your account object. Everyone has this. Every website, consumer, enterprise, everyone has their accounts and their users. Probably no reason why you really need a relational database for that. You're probably not doing any interesting Cartesian products between tables. You're just looking up the account by ID. You may be following the account to have a pointer to its user, or the user has a pointer back to account. There's a few different ways of modeling it. Really good for user form data. So you have user forms. You just want to store that data back in a database. You might change the form often, so the flexible schema of MongoDB is really great because you can add fields, remove fields. It's not going to impact things. Content management systems also a place where this shines. CMS systems are where you'll often see the table inheritance problem. So how many people have seen where you have a parent table representing a certain type of thing, and then you have all these children tables that point up to the parent table. So the parent table might be like the content item. And then you might have blog post or news article, offer of the day might be another subclass. And in your programming languages, this really is a hierarchy. And then you go into your relational modeling exercise and you create a parent table and all the subtables with the pointers up, and then you do the joins between them to get all the attributes. And then if you want to find out information across all of those different subtypes, then you're doing all sorts of interesting union things and all that type of stuff. Whereas in Mongo, maybe you would put a field in there that represented the type, so you could discriminate based on that. But you would just put the things that represent blog posts in the blog post type, and you'd put the things that represent the tip of the day or the deal of the day or the coupon of the day in that. You could have them all in one collection. They don't all have to be exactly the same. Great use case for MongoDB. Storing geodata, so anything that's geo-based, like location-based apps, mobile apps, really great because MongoDB understands geodata natively. So that's a big win. App configuration, really good. So everything from ports and connection info to really complex IOC kind of dependency injection type stuff, right? Really, all the stuff you want to use to configure your application, stick in JSON data structures. It's very convenient. And then application logging. A lot of people use MongoDB for app logging instead of log files. MongoDB is famous for its write performance, and a lot of people just fire and forget into Mongo, one big collection, then they can search it later as a database collection instead of trolling through log files. It's really convenient. Okay, well, that went quicker than I thought. Let's Q&A. Mention that. That's a great question. So the question is, what's MongoDB's technique for normalization when you do want to normalize your data? So let me just quickly go back. So the one thing I did not show here is that there actually is syntax for references to items in other collections. So I won't draw it here, but you have a little syntax where it's a tuple where you name the collection and the ID of the other thing in the other collection, and it's a pointer to something. So you could take the author out and put it in another collection and point to it, and you can model your data that way if it makes sense for what you're doing. So first of all, I promise, right? We did not meet before this, did we? Right. Okay. So I'm with MongoLab, and we are a hosted provider of MongoDB. But yeah, so we host on EC2 and Rackspace. We can talk afterwards. I don't want this to be a pitch session, but yeah, there are hosting, and we're not the only one. So great question. So the question is there support for constraints on the data, ways of specifying, for example, that a certain field cannot be null? In general, not really. I will say that when you specify indexes on things, you can specify that they have to be unique, and there are a few constraints like that, but really, that's not really truly what you're asking, and so the answer to your question is no. You do it in your application. I will say that in the community, a lot of open source projects have cropped up that wrap the MongoDB drivers that come from 10gen, these little mapping layers. And most of those I know of do add some sort of constraint language or constraint system, but it's handled at the application tier. Question: how does MongoDB handle concurrent reads and writes? Is there a locking mechanism on the database? The answer is yes. There's a server-wide write lock that basically, when you write, it blocks other writes and it blocks reads for the duration of that lock. For every database, for every collection on that database server. It is something that's being worked on actively. It's first going to go down to database level, and then it's going to be at an even finer grain of collection level, and then even file system extent and document level. So that's going to get better. Right. So the question is there any support for dealing with concurrent access to documents? And one example is a read if modified flag or some sort of mechanism like that. So the main mechanism MongoDB handles that is with the atomic operators I was mentioning. So all of those operators, one of them, the most simple one is called set, where you set a field to a specific value. If you update your database with one of those operators, it is guaranteed to be atomic, and you can set multiple fields at once. So in the example I gave before, this is the example I gave before, where it says atomically push this new comment onto the list of comments. I could have also said there, not only push the comments, but then increment a number. So I can actually do a modification of multiple fields at the same time atomically, and it's guaranteed that all of those will update at once. Got it. Got it. So I think what you're asking is there also a way to specify a query constraint along with that update? To say, push this on only where the ID is 55 or only where this thing is not null, or set it to 7 if it's not null, or set it to 12 if it's less than 10, but if it's more than 10, do nothing, that kind of thing? Okay, so the first part of this update operator is a query constraint. So that query and the update happen together. Yes, sorry, I was not clear. No. So, okay, so the question is, you can get atomic operators on a single object, but what about across objects? So one of the things that MongoDB is not well suited for are applications where you need multi-operation transactions, right? So the idea of saying insert, 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 update, update, delete, delete, uh-oh, roll all that back, or commit all that together. The kind of two-phase commit stuff. MongoDB does not support that. What is the support for querying nested arrays? Would that be correct? So one operator I did not show is called LM match, and you can look this up on the docs online, but it's actually particularly for matching those things that have arrays with elements that match a query that you specify. And that should work fine. I've never personally done it on arrays of arrays, but in principle it should work. Sorry, the question is there a way to substitute the way you compute geosearches, the way you compute distances between things, I think is what you're getting at? Not that I'm aware of. I think it's really just spherical coordinate computations, and that's it. Or spherical, I think there might be spherical and Cartesian, but nothing where you can kind of plug in your own version of the distance formula that I'm aware of. Oh, great. Yeah, so the question is, how do you back up these databases? There are a variety of techniques. So you can use, okay, so the main ways folks do it are, there are some built-in commands that come with MongoDB. One is called Mongo export and one is called Mongo dump. Mongo export exports, it's more of a human-friendly export, exports into either CSVs or JSON files. Mongo dump is a binary dump format. The technique you use with Mongo dump, depending on if you have journaling and replication on, is either you run Mongo dump and it'll actually properly back up the database, and you can have it do a point-in-time backup without having to stop it. In other scenarios, you can do what's called an fsync and lock, where you basically tell the database to flush everything to disk. You suspend writes to the database, and then you dump the data, or you can alternately copy. It's also depending if you have a small data set, you can copy the database files. One nice thing is it's very clear what's going on under the hood. There's a directory with files and for your database, and you can copy those over, and you can be sure that if you copy those over, that represents the whole thing. If you're on something that supports journaled snapshotting, so if you have a journaled file system, EBS supports this. There are other journal file systems. You can do incremental snapshots. And let me think what some of the other ways. Those are the main techniques. And they're pretty well documented on the MongoDB site. And you tend to, one thing I'll say also, replication is often used for doing backups. So one thing that's typical is, instead of doing backups off of a master and affecting the performance of that node, you can have a slave that's devoted as a backup slave. So you replicate to that slave, and then you take backups off that slave, and you're not affecting the actual primaries that are serving your application. Okay, so thank you very much, guys.